Okay, so imagine this scenario. It's the dream we are all being sold right now.
Right.
You have a brilliant business idea, you type it into a prompt bar, you hit enter, and then you go to sleep.
The passive income dream.
Exactly. And while you're dreaming, an army of AI agents just spins up. A swarm.
Uh-huh.
One agent writes the code, another designs the logo, a third one, I don't know, it handles the LLC filing, and a fourth starts running Facebook ads.
You wake up and you're a CEO.
You wake up, you pour your coffee, and your business is already running. That is the promise of agentic AI.
It really is the current holy grail of the tech world. The idea that we're moving from chatbots, which, just talk to agents, which actually do things.
Right. But we have a stack of research today, some articles, white papers, some really dense theory that suggests if you try to build that dream swarm right now, you don't wake up to a business empire. You wake up to a digital burning building.
A very expensive and very chaotic burning building.
So today we're diving deep into an article called Organizational Theory as the Foundation for Agentic AI Systems.
Right.
And the core thesis here is something that I think is going to surprise a lot of people. It claims the reason these AI swarms are failing isn't because the code is bad. It's not because the models aren't smart enough.
It's because we've forgotten how to organize.
That's the twist. We're trying to solve this with more compute, more GPUs, bigger models.
But this deep dive argues it's actually a management problem. The solution isn't in a microchip. It's in a dusty management textbook from the 1950s.
Which I love because it means we're going to fix the future by looking at the past. Our mission today is to basically build an org chart for software.
An org chart for software.
We're going to find out why agentic AI is hitting a wall and how concepts like span of control and bureaucracy, words I usually hate, might actually be the only way to save it.
It's so ironic. We're using the most advanced technology in human history just to rediscover why middle managers exist.
Please don't tell me the future is just more middle management.
I can't promise that.
Okay, before we get into the dusty textbooks, let's define the beast. We hear agentic AI thrown around constantly. My smart speaker sets a timer. Is that an agent?
No, not really. That's just a command. Agentic AI is distinct because of autonomy and loops.
Loops.
Yeah. If you ask a standard chatbot to write an email, that's linear. Input, output, you're done. An agent is different. You give it a goal, like manage my inbox.
So it has to figure out the steps on its own.
Correct. It has to open the inbox, read the emails, evaluate what's important, draft replies, maybe delete the spam.
And then do it all over again.
And then execute those actions. It is a loop. Plan, act, observe, repeat.
Okay, so it's not just answering a question, it's performing a job.
Right.
And the research says that when you have a small team of these agents, say 3 to 5 of them, it works like magic.
It does. You might have one agent acting as the researcher, finding data. Another agent is the writer, drafting the content. And a third acts as the editor.
And at that scale, 3 to 5 agents, they coordinate beautifully.
Perfectly.
But the source material highlights this specific failure mode they call the scale wall. What happens when you try to scale that up, say from 5 agents to 50?
The system it collapses.
Yeah.
The data indicates that once you cross a threshold of about 10 agents, the performance doesn't just plateau.
Yeah.
It completely nosedives.
There was a stat in the reading that really jumped out at me. It said a workflow where the individual agents are like 90% reliable.
Yeah.
It drops to something like 35% total reliability when you scale it up without structure.
Think about that. 35% reliability. I mean, that is essentially unusable for enterprise software. You can't run a bank or a hospital on 35% reliability.
And it's not just that it breaks, it gets incredibly expensive.
Oh, yeah.
The source mentioned that token usage, which is basically the bill you pay to run these things, explodes by a factor of 3 to 5 times.
This is the hidden cost of chaos.
But why? If they're failing, what are they spending all those tokens on?
They're spending them on arguing.
Arguing.
Well, the technical term would be clarifying or negotiating context.
Yeah. Okay.
Agent A generates an output. Agent B receives it, but doesn't quite understand the context because there are 40 other agents chattering.
So Agent B has to ask for clarification.
Right. And then Agent C jumps in with a conflicting instruction.
So they're just spinning their wheels.
Exactly. Suddenly you have a massive feedback loop where the agents are spending 80% of their compute power talking about the work and only 20% actually doing the work.
It sounds like the telephone game we played in kindergarten.
Yes.
But every time someone whispers, it costs the company 10 cents.
And the information degrades at every single step. By the time the instruction reaches the 20th agent, build a secure login page has turned into delete the database.
So the root cause identified here is pretty interesting. The article argues that we're making a fundamental assumption error.
A huge one.
We assume that because these are computers, they have unlimited managerial capacity.
We look at an orchestrator agent, the boss bot, and we think, it's a large language model trained on the entire internet. Surely it can manage 50 direct reports.
But it can't.
It can't. It has a limit, just like us.
And this is where we have to open the history books.
Let's talk about Lyndall Urwick.
1956, the golden age of management theory.
Urwick gave us the concept of span of control. He said that a human manager can only effectively supervise between, say, 5 and 7 people.
5 to 7, that seems low.
It seems low until you try to manage 8. Urwick argued that beyond that number, you're just dying. You can't track the personalities, the context, the interdependencies of the tasks. The relational complexity explodes mathematically.
I think anyone who's had a boss with 20 direct reports knows this is true. They don't know what you're doing. They have no idea if you're drowning.
Exactly.
But does this apply to AI? They don't get tired. They don't have personalities to manage.
They don't have fatigue, no, but they have context windows.
Okay, let's unpack that for a second, the context window.
Think of the context window as the agent's short-term memory, or its attention span. It's the amount of text the model can hold in its head while it's working on a problem.
Like a whiteboard.
Exactly like a whiteboard with limited space. If an orchestrator agent is trying to watch 50 sub-agents, that whiteboard fills up immediately.
Agent 1 did this, Agent 2 failed at that, Agent 3 needs help.
The context window just saturates.
And when an AI's context window gets full, what happens?
It starts forgetting. It suffers from what we call the lost in the middle phenomenon. It might remember the first instruction and the last instruction, but it forgets everything in between.
It literally runs out of space to hold the state of the project.
So the boss bot gets overwhelmed, the whiteboard is full, and it starts hallucinating to fill in the gaps.
Okay, so the fix proposed by the source is structure. You can't have a flat organization.
You need a hierarchy.
Enter the middle managers.
So you have an orchestrator managing 5 manager agents, and each of those managers oversees 5 worker agents.
I can hear the Silicon Valley disruptors screaming in agony right now.
Oh, no.
We're recreating the corporate ladder. We're building a bureaucracy.
We have to. It is the only way to manage the information flow. The source points to Anthropic's constitutional AI as like a primitive version of this.
Where they separate the critic from the executor.
Right. It's a 2-tier hierarchy.
And we are seeing this with OpenAI's O1 model too, right? It's not explicitly multi-agent in the interface, but under the hood, it's doing something similar.
Yes, O1 uses what they call chains of reasoning. It breaks a complex problem down into steps and manages the execution of those steps logically.
So it functions like a manager decomposing a project for a team.
It prevents the model from trying to solve the whole universe in one go.
It's compartmentalizing. You worry about this piece, I'll worry about the big picture.
Precisely. It manages the span of control.
Okay, so we've established we need an org chart. We have a CEO bot, some VP bots, and low worker bots.
Yeah.
But now we need to talk about how they actually talk to each other. Because right now, most of these agent demos I see just look like a messy group chat.
That is the second major trap, the chat log trap. Currently, most multi-agent systems just pass unstructured text back and forth.
Which is like running a Fortune 500 company entirely through a single unending Slack channel.
It's a nightmare.
That sounds like my personal nightmare. Project update. And the poor agent down the line has to parse 5,000 words of back and forth just to figure out the font size of a button.
And because LLMs are probabilistic, they're just guessing the next word. If you give them a messy, ambiguous chat log, they will eventually guess wrong.
Which brings us to a concept from, starring Griesmer, 1989?
Yep. Boundary objects.
Boundary objects. It sounds incredibly academic.
It does, but it's actually very practical. A boundary object is just a shared artifact that different groups use to coordinate without needing to talk constantly.
Like what?
Think of a blueprint for a building.
Okay, a blueprint.
The architect draws it. The plumber reads it to know where the pipes go. The electrician reads it to know where the wires go. They don't need a 3-hour meeting to agree on where the wall is.
The wall is on the blueprint.
The blueprint is the source of truth.
So in the AI world, this means we need to stop sending chat logs and start sending what?
Structured data objects.
So instead of an agent saying, hey, can you build a login feature, it sends a JSON file.
Exactly. A requirements object. It has specific fields, user story, acceptance criteria, error states, constraints. It's basically a form.
This reminds me of how human software teams work. You don't just email a developer saying, fix the bug.
Right.
You open a ticket in Jira or Linear. It has a priority field, a description field, a screenshot field.
And that structure is so crucial for AI. It reduces the entropy, the randomness. If an agent knows exactly where to look for the acceptance criteria, it won't hallucinate them based on a casual comment 3 messages up.
It also unlocks parallel work, doesn't it? That was a big aha moment for me in the reading.
That is the killer feature. If you have a structured object, one agent can be working on the database schema section,
While another is doing the front end.
while another agent is simultaneously writing the front-end code based on the UI design section. They can work at the same time.
They align around the document, not the conversation.
Right. It decouples the communication from the execution. You stop the bottleneck. You don't have to wait for the chat to finish to start working.
Speaking of decoupling, that leads perfectly into the third solution. The source talks about coupling and bounded rationality. Now, bounded rationality is Herbert Simon, right?
Herbert Simon, yeah, a giant in the field. Won a Nobel Prize for this.
Yeah.
Bounded rationality essentially says, we're not gods. We have limits.
Limited attention, limited time.
Limited processing power. We're not optimizers. We are satisficers. We find a good enough solution.
And for AI, this goes back to that context window. You can't just feed an agent the entire history of the company and expect it to remember a sticky note from 1998.
It gets lost in the middle.
So the organizational fix is specialization.
Yes. Do not build generalist agents. Don't hire a jack of all trades who tries to do the database, the design, and the marketing copy.
Because their bounded rationality gets spread too thin, they become mediocre at everything.
Exactly. You want a security review agent that only knows the security standards. It doesn't know about color palettes. It doesn't know about marketing tone. Its context window is 100% focused on security.
But if you have all these specialists, a security guy, a database guy, a UI guy, how do you manage the flow between them?
That's where coupling comes in.
And the source used a Toyota analogy here that I thought was brilliant.
It is. It's the concept of calibrated coupling. Think about a car assembly line. That is tight coupling.
Just in time.
It's just in time. If the person putting on the wheels is slow, the whole line stops. Every step is physically and temporally locked to the next one.
Which is efficient if everything works perfectly, but super fragile if one thing breaks.
Right. Now think about Toyota's suppliers. Toyota doesn't manage the tire factory with that same tight coupling.
That would be chaos.
They're loosely coupled. Toyota just says, we need 500 tires delivered on Tuesday.
They don't care if the tires were made Monday morning or Monday afternoon.
As long as they arrive at the interface, point the delivery dock on time.
So how does this translate to our AI swarm? When do we use the assembly line? And when do we use the delivery dock?
You have to choose your architecture based on the task. If you have agents generating code where function B depends entirely on function A working first.
You need tight coupling.
You need tight coupling. The orchestrator needs to check every single step.
Because if the foundation is wrong, the whole house falls down.
Exactly. But if you have a research task, say, map out the competitive landscape, you don't want the boss checking every Google search. That slows everything down.
You loosely couple it. You tell the research agent, here's the goal, come back in 30 minutes with a report.
You let them run wild, then you integrate at the end. If you tightly couple everything, you get a bottleneck. If you loosely couple everything, you get incoherent chaos.
It's all about finding the balance. Okay, so we have the hierarchy, the middle managers, we have the structured documents, the blueprints, and we have the specialists with calibrated coupling. But there's still one last hurdle, and it's arguably the most human one.
Language.
Language. Communication protocols. The source points out that improved code quality means different things to different agents.
This is the Tower of Babel problem. These models are trained on the entire internet. To one model, quality might mean make it run faster.
Okay.
To another model, maybe one trained on Python best practices, it means add more comments. To a third, it might mean refactor the whole thing to be more concise.
And suddenly your software is broken because 3 agents tried to improve it in 3 different directions.
The fix here is establishing ontologies.
That is a $10 word.
It just means a shared dictionary, a shared view of the world. The source uses Boeing as the example.
Right.
When thousands of engineers work on a fuselage, they have a strict mathematical definition of what maximum load means. They don't guess.
You can't hallucinate the structural integrity of a plane.
Exactly. And AI systems need that same rigor. We need standardized templates and definitions. And there's a specific technique mentioned called read-back protocols.
Like in aviation, Tower, clearing for takeoff.
Roger, cleared for takeoff.
Yes.
In an AI system, before an agent executes a task, it should restate the task to the sender.
So it would say, you want me to refactor this code to improve speed, correct?
Yes, and this catches the misunderstanding before the tokens are spent.
It effectively forces the agents to sync their mental models. It seems so simple, but I bet it saves a fortune in wasted processing time.
It changes the reliability curve completely. You catch the error at the handshake, not at the finish line.
I want to zoom out for a second. We've talked about the tech, the theory, the structure, but let's talk about the people building this, because the source makes a really provocative point. If you just put a bunch of machine learning engineers in a room, you might not get the best organization of agents.
Right. The skill set required to build these systems is shifting. It's not just about tweaking weights in a neural network anymore. It's about organizational design.
And the source argues you actually need organizational psychologists and domain experts in the room.
It compares it to IDEO's cross-disciplinary teams, or P&G's Connect plus Develop. If you're building a customer service swarm, you don't just need someone who knows Python.
You need someone who knows how customer service teams actually coordinate.
You need to know where the friction points are in a human conversation so you can design the agents to handle them.
And you need governance. This part reminded me a lot of the Microsoft Responsible AI framework.
It's the idea of risk-based oversight. Not all agents are created equal. If you build a recipe bot that suggests dinner ideas, you can have very loose governance.
If it hallucinates and tells you to add too much salt, you just have a bad meal.
Right, no big deal. But if you're building a financial trading bot,
that needs strict agent governance.
High-stakes decisions need a human in the loop. You need to design the org chart so that any transaction over, say, $1,000 gets flagged and escalated to a human manager.
It's funny, we're basically recreating the corporate handbook, chapter by chapter.
Escalation policies, approval limits, middle management.
The source actually outlines a maturity model for this. Most companies right now are at level 1, ad hoc.
Just trying to prompt their way out of problems.
Please, AI, just work.
Right. But we need to get to level 5, optimizing. This is where the coordination patterns are documented, measured, and systematically improved, where you treat the organization of the agents as a product itself.
So to summarize our mission here, if you want scalable AI, stop looking for a smarter model.
You need a better org chart.
Yes. You need hierarchies to manage span of control. You need structured boundary objects instead of chat logs.
You need calibrated coupling. And you need clear communication protocol.
It's structure over raw intelligence.
Which is the story of human civilization, really. We didn't build skyscrapers because we individually got smarter than our ancestors.
We built them because we got better at organizing.
We developed blueprints, contractors, supply chains.
Yeah.
We scaled our collective intelligence.
That is a powerful thought. But it leads me to my final question for you and for our listeners to chew on. We've spent this whole time proving that to make AI work, we have to make it look like a human corporation. We are giving them managers, forms, bureaucratic layers, and specialized roles.
I think I know where you're going with this.
If we design these AI agents based entirely on human organizational theory, are we destined to just recreate the same bureaucracies we hate, just at the speed of silicon?
It is a distinct possibility. We might solve the coordination problem, only to discover we've invented AI middle management bloat.
Are we going to have AI agents complaining about their micromanaging boss by the digital water cooler?
We might. And if we do, we will know we have truly succeeded in replicating human intelligence, flaws and all.
A terrifying thought to leave you with. Thanks for diving deep with us.
Always a pleasure.